Hi everyone, welcome to this week's lecture, which is all about psychometric instrument development. So before we get started, the overview of today, we're first gonna do a revision of exploratory factor analysis. And then from there, we're gonna build upon our thinking and discussing about what concepts are and how to measure them, measurement error, psychometrics, reliability and validity, and then creating composite scores. And this lecture today is really an extension of many of the components we talked about in last week's lecture for exploratory factor analysis. So this week's lecture really builds upon that with some key components. Before we do that, let's go into the recap. So we had a mammoth lecture last week, which was all about exploratory factor analysis. And as a reminder, factor analysis, it is really the correlational methods used to identify clusters of covariance, which are called factors. So you have your survey, which has a number of items or questions in them, and you want to ask the question of, can the items within these surveys, do they cluster into meaningful factors and perhaps have shared variance that could be explained through these factors? And so you have the theoretical purpose of factor analysis, and in that case we'll use principal access factoring, and then you have the data reduction purpose, which is through principal components analysis. And we talked about how there were two main types of extraction methods: exploratory factor analysis and then confirmatory factor analysis. But really, the focus of the lecture and in this course is on exploratory factor analysis. But I just want to make you aware that there is something called confirmatory factor analysis, and it's largely used in research, but it is a little bit more complex, and understanding exploratory factor analysis is sort of the first step to knowing more about it. So there are 8 key steps to take away from factor analysis to be able to know how to undertake a factor analysis. So hopefully you have a good sense of, with these steps, not just knowing what these steps are, but for each of these questions, a good test would be to stop the video and ask yourself, do I know each of the components within these steps? Because that will demonstrate that you have a good understanding of what the assumptions are for factor analysis and how to conduct it. So the first step is, as with anything in statistics, is you have to test your assumptions, right? Can you do the analysis on your data? And we'll go through these in a bit more detail in a moment. And then we talked about how you select your method of extraction. So are factors likely to be related, or are they unrelated? Determine the number of factors. So how many factors do you think make sense? What is the data telling you? This is where you have the enmeshment of your statistics that provide you with some guidance, but really your judgment as well, based on the literature, based on what's meaningful, based on the items themselves. There were a whole bunch of components that were influencing how we think about determining a factor structure, realizing that in some ways justification is what it's all about, because there are examples, for example, in personality literature, where some people think a 3-factor structure versus a 5-factor structure versus a 15 factor structure, like they all have different rationale for their arguments, and they all can be applied, and their justification is laid out very clearly. And then you select the items that fit within each factor. Then you name and define each factor. So do these factors make sense? And then examine correlations amongst factors. So to what extent are they related to each other? And then we analyze internal reliability. Do the items in each factor contribute to a reliable scale, and then a subscale, and then we compute composite scores. So that's really the steps that you take. Hopefully, when it comes to testing the assumptions of factor analysis, the first thing that came to your mind was the sample size requirement, because I think I mentioned in the previous lecture, and I know I mentioned that it's a hungry sort of statistical analysis. It's data hungry. It needs a lot of data to be able to run. And so there's a whole bunch of guidelines that are provided. As an example, at a minimum, more than 5 cases per variable. So it's a 1:5 ratio for variables to cases ratio. So if you have 10 variables, you'd expect to have at least 50 cases to be able to run the factor analysis. Ideal is more than 20 cases per variable, so 1 to 20 ratio, so variables to cases. And the total number of cases should be at least 200, ideally more based on Comrie and Lee guidelines. And so they provided this sort of threshold of 50 cases is very poor, 100 is poor, 200 is fair, 300 is good, 500 is very good, and 1,000 plus is excellent. The key takeaway, in addition to these guidelines, is that for factor analysis, more is better. And you can even see how in some ways these guidelines don't really align very well, right? So here it says for the Comrie and Lee guidelines, 50 cases is very poor. But at the top it says at least more than 5 cases per variable, like a 1 to 5 ratio. So that would allow you to do it within 50 cases, right? So it's all, but they're all really trying to say the same thing. The same message is that to conduct a factor analysis, the larger your sample size, the better, and these are sort of minimum guidelines. But in any case, if you have a very small sample and you're conducting factor analysis, this would be something to consider in the interpretations of the factor analysis. So when you have your results, you'd be considering it within the context of the low sample size. Excellent. The next thing, as we always do, is in statistics is talk about level of measurement. So in order to be included in an exploratory factor analysis, your variables must be suitable for a Pearson product moment correlational analysis. So what does that mean? Hopefully you're screaming at me. Of course it means that they're interval or ratio, right? So that is the key thing that is needed for a factor analysis to be conducted. The measures have to be interval or ratio. And then we talked about normality. So factor analysis, it can cope with minor violations of normality. So it's relatively robust in that sense. But ideally, it works best if the variables are normally distributed, but they don't have to be. So this is where there's some subjectivity in the process. But when you identify your variables, the first step is to see, are any of those variables non-normally distributed, and flag that in the process as you progress through. We talked about outliers. So factor analysis is sensitive to outliers, including bivariate outliers and multivariate outliers. We talked about ways as to how we could identify that through scatter plots, statistical tests like Mahalanobis distance, and you could the ways to address them is to either remove them or recode them if they're influential. And typically people remove outliers or run analyses with and without outliers to see how the results change. And if there's no change, you retain the outliers within the sample to preserve your sample size. Linearity in factor analysis is based on correlations between variables. So remember that correlations are a measure of the linear association between variables. So it's important to check the variables are linearly related. So that comes down to checking the scatter plots, right? Then once you've checked those assumptions about outliers, if there's linearity, level of measurement, normality, sample size, then you come into the whether factor analysis is something that is possibly viable within this data set. And how do we assess that? Well, we look at a correlational table and we see whether there are sufficient intercorrelations amongst the items to warrant a factor analysis. So we assess factorability via one or more the correlation matrix correlation. So you look at the correlation table and we see, are there clusters of, are there lots of correlations that are greater than 0.3? And also you're looking at clusters of correlations as well, because that's what factor analysis is, right? These clusters of correlations. The anti-image matrix diagonals are greater than 0.5. And then also we have the measures of sampling adequacy. So with Bartlett's test of significance and the KMO, whether it was 0.5 or 0.6, above 0.5 or 0.6. And so if all of those data points align, you get a good sense that your data set is factorable, and you get some factor structures from that. So those were the key takeaways from that assumption. Now, once you've progressed through those assumptions, and you can see that there's a lot, and in statistics, this is why you don't just dive straight into analyses, or else it's not really going to be interpretable. There are so many steps along the way that could influence the way in which your interpretation could be made. And so if you haven't done the robust checks of each of those steps, then the results that you have may not be meaningful, or likely are not meaningful. And so once you've done those steps, we choose the method of extraction. So there are two main approaches to extracting factors. We have principal axis factoring, and then we have principal components analysis. So principal axis factoring is analysis of shared variance. So it's used to discover the underlying structure of a set of variables. And it analyzes only the common shared variance. So it leaves out variance that is unique to each measurement item. Principal components analysis, however, analyzes all variance. So it's more common, this type of analysis. It's used to reduce many variables down to a smaller number of factor scores, which can then be used in other analyses. So it analyzes all the variance in each variable, common and unique. So those are the key takeaways from principal axis factoring, and then what principal components analysis does, which is slightly different. So which one should you use is the key question. Well, funnily enough, often there's very little difference between principal components and principal axis factoring. And if they come to different solutions, try to work out why and decide which is more appropriate for your data. But really, it should be driven by whether you're interested in the shared variance between variables, or you're actually interested in analyzing all the variance. And that's really the determining factor of whether you want the principal axis factoring or principal components analysis. Excellent. So remember, the goal is to explain the variance, right? So a good factor solution is one that explains the lion's share of the variance with the fewest factors. In general, we tend to be happy if we can explain 50 to 75% of the variance, but as I said last week, don't be too strict on this rule. But really, that's the key goal that you need to keep in your mind when you're conducting factor analysis, is how do I explain the most amount of variance with the least number of factors? Yeah. And so then we talked a bit about rotating the solution. So a rotated solution is generally easier to interpret. We have orthogonal, which is Varimax and Jamovi. It minimizes the factor covariation and produces uncorrelated factors. Oblique, which is Obleman and Jamovi, allows factors to covary and allows correlations between factors. So really, you want to see whether you think the factors would be related or not. And I showed you how you could also work through the process, check the relationship between the factors, and see which one, whether an orthogonal or oblique, would be more suitable. So, yeah, sorry, I got ahead of myself. So are you expecting factors to be related or unrelated? So if related, choose oblique. If unrelated, choose orthogonal. If you're unsure, choose oblique, then switch to orthogonal if the correlations between factors are smaller than 0.3. So you could try both and see which solution is also most interpretable. I think the biggest, I wouldn't say shock, but surprise for students as they undergo advanced statistics is realizing the cyclical nature of conducting statistics. Often at times, you're using what you see to inform the process as well, particularly in factor analysis, to get the most interpretable solution. And so that's a process that's sort of iterative over time. And so what you don't want to be doing is just saying, okay, I'm going to make these decisions, I'm going to run the analyses, see what the results are, and then move forward from there. Because the interpretation of the results can be improved through this iterative process of checking, should the factors be related, should they be unrelated, should I change the number of factors in the solution, should I be using principal components or principal axis factoring. All of these components of the factor analysis should be considered. The overarching goal is to enhance the interpretability of the solution. So that is really the key takeaway for you. How many factors do you have? Jamovi will give you the same number of factors as variables that you have. If you have 20 variables, you'll get a 20-factor structure. It's up to you to decide how many factors there should be out of those 20. So there's no definitive statistic that tells you. You have to make your decision based on which solution explains the largest amount of variance with the smallest number of factors. What does the theory say? So what did you predict in terms of the number of factors? What are expectations? Kaiser's criterion, which is that factors are more stable when they're greater than 1. So which eigenvalues are greater than 1? Where is the elbow in the scree plot? How interpretable is your last factor? And which solution fits best? Type of exploratory factor analysis, rotation, number of factors. So fundamentally your factor structure must be interpretable and make theoretical sense. And so these are guidelines, but again, this is where in statistics you have the statistics is the tool that helps you make sense of your data, and you as the researcher apply your knowledge of the theory, your knowledge of what you expect to see, and your understanding of the data to inform your interpretation. The best skill you can learn as you're going through your journey of learning statistics is to really, when you're reading papers, to not rely on the conclusions of authors, but to actually look at the data and see their justification, see if it matches your own justification, and whether your interpretation of the data would differ. Once you develop your confidence and expertise in statistical analyses, these will be the types of things that you can look at. You may look at a paper that has done exploratory factor analysis and say, actually, I think X factor structure would have been better. It aligns better with the theory of what we'd expect to see, and these items actually form together to make interpretable factor there. So that sort of factor is best. And so these are sort of the different justification, and this is why the course is all about justifications, because statistics is all about justification. And no matter how much we try to, in our teaching of statistics, provide guidelines and guidances around what you should be doing at each step, fundamentally it is not a black and white process. There's an artistry to statistics, and that comes with time and practice, seeing what others are doing, trying your own way, and seeing what others think about it, and going back and forth. So that's just the journey of statistics there. So how do we select items? Well, it depends on using factor loadings to help identify which items belong in which factor. So an exploratory factor analysis of a good measurement instrument ideally has a simple factor structure. So each factor, each variable loads strongly, so greater than 0.5 onto only one factor. So you have all your variables, and you want each ideally, each variable loads strongly on just one factor, so you don't have cross-loading. And then each factor has multiple loading variables. And so what I mean by that is the factor itself has many variables that load onto it. So more loadings onto a factor means greater reliability. If you have 5 items or variables that load strongly onto one factor, you have greater reliability than if you have 3 items loading onto that single factor. And sorry, this is what I alluded to earlier. Target loadings are high, cross loadings are low. So with few intermediate values, you can have intermediate loadings, but you want to ensure that overall the items or variables are loading strongly onto one factor and not strongly on many others. And then you want to eliminate one variable at a time, then rerun the exploratory factor analysis. This is key. You don't want to be making, even though you could identify multiple changes that can occur, think about what is the change you want to make first, and then do that, run the factor analysis, see how it changes, then make the second change. If you make too many changes, because it's all of the output of a factor analysis is influenced by what's in the model. If you're making too many changes, it could change the model in unintended ways. So my recommendation is always one step at a time with the iterative process of conducting a factor analysis. So the steps that we went through was examine assumptions, choose extraction method and rotation, determine number of factors, select the items, name and describe factors, examine correlations amongst factors. And then we will be doing today is analyzing internal reliability and computing composite scores and check factor structure across subgroups. So that's really the steps to take for the factor analysis. In saying that, I think what we'll do is we'll take a break there. And I think before you go for break, try to reflect on everything that we just covered in that overview. and identify, are there things that you don't understand fully, and if so, what are those things? And go back to the lectures for those components. They're split up into videos for a reason. It's to ensure that they're split into meaningful concept chunks that you can investigate and say, okay, I actually need to just review this part, this 10-minute section again, to make sure I fully understand it. And then check a Wikipedia page about factor analysis, or use any other additional resources to help with your understanding, to supplement what you see, because these are well-known, well-understood constructs in statistics. So any resource you find in relation to factor analysis will definitely be of use to supplement what you're seeing in the lectures. There's this great quote I heard from a student who was studying advanced mathematics, and he said mathematics, which of course is very closely related to statistics. He said, when I study advanced mathematics, I go through this process of learning more. I understand a lot more. Then I think I understand a concept, and then I read more, and then I'm more confused, and then I read more, and then I understand a bit more, and then I think I understand a concept, and then I read more, and I'm more confused. And I thought that was beautiful, because it really does reflect, even in my own journey of learning statistics, this constant depth of process. For you learn a concept, you feel like you have a good understanding, you read more and more, and then you get a bit confused, then you learn more, and sort of, it is this cyclical nature. And so I guess what I want to emphasize with that brief story is the fact that you may have a good sense of what's going on in factor analysis, but I'm sure that the more you'll read, the more you'll learn, and you may get a bit more confused, but there'll be more understanding on the other side of that confusion. So it's a very rewarding process, and so stick with it, and also keep in your mind what you need to understand for the purposes of this course, which is what's in the lectures and tutorials and whatnot, but also keep in mind in your journey of statistics that whole cyclical process that occurs is important. The more you can sort of work through those challenging moments, the other side of it will be more understanding. So I think it's a good way to conceptualize it, and certainly an important reminder after the mammoth lecture on exploratory factor analysis and this overview on it. But check your understanding, take a break, stretch your legs, grab a tea, and I'll see you in the next video. See you very soon.